Okay, now let's look at a few properties of barycentric coordinates. The first property is that this is indeed a coordinate system. So which means that uh, every point in the plane gets exactly one triple xyz of barycentric coordinates. So how can we see that? Recall that we have already proved that the choice of the origin does not matter for barycentric coordinates, that does not affect the values of xyz. And so which means that if we can prove that this is true, uniqueness, existence and uniqueness of barycentric coordinate is true for a particular choice of the origin, then it's going to be true for all choices of the origin, right? So we have, let's say, A, B, and C. A, B, and C, our 3 points. Well, and then generally we could choose the origin somewhere, but let's just put the origin into A. So our origin is going to be the same as A. And then we have our point P. So then we have our vector from A to B, from A to P, from A to C. Now, then, so we have our vector A, P, what we want, right? So what we want. So we want to show that AP can be expressed as X times the vector from A to A, which is just the zero vector, plus Y times the vector from A to B, plus Z times the vector from A to C. Well, but this is kind of clear, is it not? So since the multiplier at x is just the zero vector, we can ignore it for a while. And here we have yab plus zac. So which means that y and z are just coordinates of the vector ap with respect to the coordinate system where unit vectors are ab and ac. And it is just the Cartesian coordinate system. It is not orthonormal, but it is still a Cartesian coordinate system, and it is very well known that such pair of y and z is unique. But if you know that such pair of y and z is unique from here, then you know x is just simply a 1 minus y minus z. That's it.